Okay, I am now officially ready. So let's do this. On number 1 and number 2, we're finding positive and negative coterminal angles. And so the big deal on this is that when we did it on the homework, most of us were good with the adding and subtracting 360 for degrees. And then with radians, some of us had more trouble. It is very important that you put the angle they gave you first so that you actually end up with the correct signs here. So 485 plus 360 gives us a really big number. Anybody know it? 845. And then 485 minus 360 gives us 125. Now we have a problem because we want a positive and a negative coterminal angle, and I got 2 positives. So then I have to say, well, what do I do to get a negative angle? I need to use my smallest angle, 125, and subtract again. So 125 minus 360 equals negative 235. And so either of those 2 positive answers are fine, but we had to have this negative 235. This question will be multiple choice, so that might make it a little bit easier so that if it was a case where you weren't sure which of these 2 answers to pick, either of those are fine. We just have to make sure we have negative 235 as an answer. Yeah?
If we did that mentally, do we still have to like write out the work?
No, it's going to be multiple choice, so I'm not going to look at your work on that problem. So if you did it on the calculator or if you did it in your head or whatever, that's fine. On the next problem, if you convert it to degrees and then add and subtract 360, that's fine, but the answers are going to be in radians. So that's actually more work than just doing common denominators. I want to add 2 pi to this because if I look at my unit circle, hopefully it says, what do you need? Okay. Hopefully it says 0 and 360 and then 0 and 2 pi on our circles, and if it doesn't, you could put that because 2 pi and 360 are the same thing. So what I need to do here is get a common denominator. I need a 3 on bottom, which means I'm going to times the top by 3 also. So that makes this 6 pi over 3. So I add negative 4 pi plus 6 pi and get 2 pi over 3. That's my positive angle. Then I'm going to do the same thing but with a minus sign in between them. So negative 4 pi over 3 minus, and go ahead and use what you got for your common denominators. So 6 pi over 3. If I subtract those, that's negative 10 pi over 3. So those are my 2 answers. And because I got a positive and a negative, I don't have to worry about adding or subtracting again. If, when I was done with that, if I could have simplified those fractions, I would want to, by the way. Questions on 1 and 2? Let's go to 3 and 4. So here, it's important to know that coterminal means 360 and 2 pi. When we're converting, we need pi and 180 because pi radians equals 180 degrees. So all we're doing is converting, just like if we were going between inches and feet or things like that. We want to get rid of our degrees, so 180 goes on bottom and pi goes on top. To work this out on your calculator, you can do 255 over 180 and press enter and then change that decimal to a fraction by doing math, enter, enter. How do I spell enter again? There we go. And so the calculator will do that for you and tell you that 17 over 12. You just need to remember to put the pi back on top. Don't put the pi into your calculator. Okay, leave the pi out and then put it back in your answer.
So is that 17 pi?
Yes, 17 pi over 12. Okay. And then we're going to do the opposite on number 4. I want to get rid of the pi and I want to have degrees, so 180 degrees goes on top and the pi goes on bottom. So the pi's cancel, which is good in math and bad in real life when pi's cancel out. But negative 175 times 180, that's not supposed to have a degree symbol. Negative 175 times 180 over 36, that's what I would do in my calculator in some order. And that gives me negative 875. Questions on those two? Okay, on the next 12, it's really important that you have your unit circle out. Because, and okay, I'll throw this out there, sometimes our biggest problem with taking math tests is not knowing what to do when.
Yeah, fine.
And so that's why when we're reviewing, we need to pay attention to the instructions, because usually the instructions are similar on the test. Sometimes they're not, and that can make things difficult. But like here it says, find the exact value. Exact value means fractions and square roots. And means not decimals, okay? It says use the unit circle, which means you better use the unit circle in order to get your answer. And then it reminds you, basically, do not write decimals. So if I type sine of 330 degrees in my calculator, it will tell me that that's 0.5, but I don't want that decimal. Hopefully we could all come up with 1/2 pretty easily from that, but it also is supposed to be, yeah, negative. Okay, because sine of 330, the way we're supposed to do this is we're supposed to look at our unit circle over here at 330 degrees, and we look at that y value. Okay, this is the point we're looking at. Sine is our y value, so this is negative 1/2 for our answer. So like on number 6, if I type this in the calculator, I will not get what my answer choice is going to look like. So I look at my unit circle at 315 degrees, which is over here, and that point should say square root of 2 over 2, comma, negative square root of 2 over 2. And what I want, because it's cosine, is I want the x value. So I want positive square root of 2 over 2 for my answer. Being able to use the unit circle is something that if you're not getting it right now, you need to let me know, because I can fix that really quickly. We just need to look at it one-on-one to help you get it. Tangent of pi over 3. So you find pi over 3, which is up here in our first quadrant, and you look at that point, which is 1/2, comma, square root of 3 over 2. Tangent is my y value over my x value. So I'm going to put square root of 3 over 2 over 1/2 and simplify. The simplification for this works the same way every time, which is why this isn't really supposed to be that difficult. The 2's cancel because there's a 2 on the bottom of both. That leaves us with square root of 3 on top and 1 on bottom, which is just square root of 3.
Can you also like do the multiply it by their reciprocal?
Yes, the reason that works is because we can multiply by 2 over 1, which is the reciprocal of the bottom, and that's why the 2's are canceling out. But if you can remember the 2's will always cancel out, then you can get there a little faster.
Okay.
So whichever way.
Okay.
7 pi over 6 is in the third quadrant. And that point is negative square root of 3 over 2, comma, negative 1/2. We want cosecant, and cosecant is 1 over y. So 1 over negative 1/2. What I'm going to do is I'm going to flip the bottom to make that work. This is like saying 1 over 1 times negative 2 over 1. Okay, 1 divided by something means find the reciprocal. So what I get for that is negative 2. The other way of looking at it that might be easier is if you remember cosecant and sine are reciprocals. Well, what is sine? Oops, I didn't mean to make that mark. What is sine? It's negative 1/2. What's the reciprocal of negative 1/2? Negative 2. These last two are on our quadrant lines, so that makes them more interesting. Pi over 2 is up here at the top. That point is 0, 1. Secant is 1 over x, so 1 over 0 is what? This is what we have to, if you aren't confident on which way is which, type into your calculator 1 divided by 0. You get an error because you can't divide by 0, and that tells you that this is undefined. When I do cotangent of 90 degrees, though, it's in the same spot as the last one. So it's the same point. Cotangent is x over y. So now I'm doing 0 over 1. I can do 0 divided by 1, and that gives me 0. It's like you're dividing 0 pizzas into one group. Well, you still have 0 pizzas. It doesn't change that fact. Okay, but I can't take one pizza and divide it between 0 people. That doesn't make any sense. That's why this is undefined, but this is 0. But if you can't remember which way is which, just type it in your calculator to check. Questions on 5 through 10? Okay, the next ones are telling us to go backwards, which sometimes makes this easier and sometimes makes this harder. It tells us to only look between 0 and 90, and this should really have a degree symbol. So we only are going to look in the first quadrant of our unit circle. First quadrant of our unit circle. Okay, because if it didn't say that, there's actually 2 answers to all of these. There's 2 places on our unit circle where these happen. So if I want to know where sine is square root of 3 over 2, I want to know where is the y value, square root of 3 over 2, in the first quadrant on my unit circle. So I look at my unit circle and I say, oh, that happens at 60 degrees. So that's my answer. And a bunch of these answers end up being 60 degrees. So if you had that happen and freaked out about it, you don't need to. It gets more difficult with tangent and cotangent and secant and cotangent and cosecant, all of those other ones. But tangent is y over x. If I want my y value over my x value to simplify to be square root of 3, looking at your unit circle, think about what has to happen. Having square root of 3 means I should have a square root of 3 on top and a 1 on bottom, and all of our points are over 2. So I just figured out what should have been in that fraction before they simplified. If my y value is square root of 3 over 2 and my x value is 1/2, which angle is that on the unit circle? It should be 60 degrees. Like I said, a bunch of these end up being 60 degrees. Cosine is 1/2, so where is our x value equal to 1/2? That one should be easy. That's 60 degrees again. There's only like 4 choices for answers on these: 0, 30, 45, and 60. So that's why so many of them ended up being 60. Secant theta equals square root of 2. Secant is 1 over x. And so they simplified and they figured out that that meant that we got square root of 2. So we have to think about, of our choices for x values in the first quadrant, which one of those is going to give us a square root of 2 when we simplify it. What I mean by that is, like, our first x value on our unit circle is square root of 3 over 2. Does 1 over the square root of 3 over 2 simplify to be square root of 2? No. Does 1 over square root of 2 over 2 simplify to be square root of 2? It does, and it's the best option because it's the only one with a square root of 2. So this ends up being 45 degrees. Cosecant is 1 over y. So where is our 1 over y going to simplify to be 2? Well, that has to happen, and that one's easier to see maybe, that has to be a 1/2 on the bottom to flip up and be 2. So where do I have a y value of 1/2 on my unit circle in the first quadrant? 30 degrees. And then finally, cotangent is square root of 3 over 3. And this one to me is the toughest because we have to understand that they rationalized this. So before they rationalized it, the square root was on the bottom. This was 1 over the square root of 3. Which means that they had 1/2 over the square root of 3 over 2. And then we can look at this and say cotangent is x over y. So x is 1/2 and y is square root of 3 over 2. So our angle is 60 degrees. Depending on whether or not you liked 5 through 16, if it matters, there's not that many on the test. So If you liked them because you thought they were easy, sorry, there's not that many on the test. If you didn't like them, don't worry, there's not that many on the test. (17) tells us that sine is 2/5 and that we're in the first quadrant and we want to find the other 5 trig functions. When you see that they give you a trig function, we're going to need to write a triangle of some sort. And so since it's in quadrant 1, I'm probably going to want to do an x and a y axis, and I want to draw my triangle over here in quadrant 1. I've seen a bunch of people on the homework drawing their triangles like backwards. Like, we want to draw out from the origin a straight line so that this is our angle, okay, because that's how we draw angles. And so that means that this is our y over our r, or our opposite over hypotenuse, however you want to think about it. So 2 and 5. If we need all 5 trig functions, we need the third side. So that's the Pythagorean theorem, which gives us 25 minus 4, which is 21. We square root that. Now this doesn't simplify because it splits up into 3 and 7, which are both prime numbers. So we would leave it as the square root of 21. Then we just need to write everything other than sine because they told us sine. And I realize you don't have a lot of room on your review, and I'm sorry about that. There will be more room on the test, hopefully, so that you won't have to scrunch things. You know, I wrote the test already, but that doesn't really mean anything, because I did it at 4 o'clock this morning-ish.
Why would you do that at 4 a.m.?
So I had time. Tangent. Tangent is opposite over adjacent, or y over x. So 2 over the square root of 21, just make sure you rationalize that. We multiply the top and bottom by square root of 21. So that's 2 square roots of 21 over 21. Every time we rationalize, it makes the square root on bottom go away. So instead of having square root of 21, now I just have 21. And it's like I'm moving it up to the top. Then we need cosecant, which goes with sine. So they told us sine was 2/5. Let's flip that and get 5/2. Secant is the reciprocal of cosine. So I'm going to flip square root of 21 over 5 and get 5 over the square root of 21, and then rationalize that by moving the square root up to the top. And then cotangent, if I flip before I rationalize, that's the easiest way to do it. Or if I just go back to my triangle and do x over y, I should get square root of 21 over 2. So those are my 5 trig functions that they didn't tell me. (18). So this one is a little trickier because they don't tell us what quadrant it is in. We have to figure it out. So tangent is -4 over 9. So either our x value or our y value is negative, but not both of them. If they were both negative, this would be positive. And then it tells us that sine is less than 0. So sine is negative. So when I draw my quadrants, what I want to do is I want to say, if sine is negative, where does that mean my triangle can't be? It can't be up here where y is positive or over here where y is positive. Because if sine is negative, my y value is negative. So since I know my y value has to be negative, and I know that tangent is -4 over 9, which is y over x, that negative is supposed to go with the 4. Okay? So x has to be positive 9. So which way does this go? Does it go to the right or to the left? It has to go to the right because it's a positive 9. So here's my triangle. 9, -4. I need my third side, so I do the Pythagorean theorem. I'm missing the hypotenuse, so both of these go on the same side. So 81 plus 16 is 97, and then we square root it. And 97 is a prime number in itself. Like, you can't split that up at all, so we just leave it as square root of 97. Now let's find everything but tangent, because we already know what tangent is from the problem. Sine is -4 over square root of 97. So we rationalize by multiplying the top and bottom by square root of 97. Let me try that again. So that's sine. Then cosine is 9 over square root of 97. So we rationalize. They already told us tangent. You can write it down again if you want to, or not. When I do cosecant, it's easier to flip what you had before you rationalize. So that's negative square root of 97 over 4. Secant is square root of 97 over 9. And then cotangent, they told me tangent was negative 4 over 9, so I'm going to flip that and get negative 9 over 4. All right, the next two problems, if you didn't do it yesterday, you might try tracing over to make sure you know what the graph looks like. I'll make sure it's clearer on the test where the graph is. But these are things from the first test, and so remember that if you do better on this test, it will replace our first test grade. So the stakes are even higher than just as a regular test. You have a chance to fix whatever your first test grade was and make it higher if you do better on this test than the last one. Our domain is our x values. So my x values go to the left forever, but they stop here at negative 2. Then they start back up at positive 2, and then they go on forever toward infinity. So the way I write that is negative infinity, comma negative 2, and a bracket because it touches negative 2. And then I put bracket 2 comma infinity.
Wait, how did you get the second part? I don't understand.
So this part of my graph right here
Yeah.
is it starts back at 2 and then it goes to the right. So that's
Okay.
2 to infinity.
Okay.
Then my range is my y value. So what I want to see is what is the top of my graph, where is that at, and where is the bottom of my graph? The very top number of my graph is 0 for y. The bottom of my graph, well, it keeps going down forever. So the bottom of my graph is negative infinity. So I write the most negative number first, so negative infinity, comma 0, and it's a bracket because we actually touch here at 0. They're not open dots, they're not asymptotes. And we don't write like a second thing because both parts of this are between negative infinity and 0. So we don't have to write another 0 to negative infinity or something like that. All of this is between negative infinity and 0. We are increasing on the left side of this and we are decreasing on the right side because if we're walking to the right, this guy's walking uphill, this guy is walking downhill. Okay, because we walk to the right just like we read. So this is negative infinity comma negative 2. You can put a parentheses or a bracket there because that's how increasing, decreasing, and constant work. This part is from 2 to infinity. Again, you can put a parentheses or a bracket around 2. It is not constant at all. If it had been connected right here, we would be constant there. It wasn't connected. I've just drawn a bunch of lines on top of that right now. So that, see, it's not connected. Is this even, odd, or neither? So even is y-axis symmetry. Odd is origin symmetry. Neither means neither of those. So I can fold this on the y-axis and it's the same on either side. So this is even. Let's look at the next graph. So our domain, left to right, we go left forever and right forever, so our domain is negative infinity to positive infinity. But our graph does not go up and down forever because we flatten out here at 6 and at negative 6. So our bottom y value is here, our top y value is here, so we're between negative 6 and positive 6. I'm gonna erase that. We are not increasing at all on this graph. We just decrease in the middle and are constant on either side. We only put our x values on increasing, decreasing, and constant. So I'm not increasing, I'm decreasing here between -4 and +2. And then I'm constant from -infinity to -4 and from 2 to infinity. Is it even, odd, or neither? Well, it's neither. If this had been shifted to the right 1 so that this point was here, it would have been odd because we would have been able to reflect it around the, not reflect it, rotate it around the origin. But it's not, so this is neither. Turning to the back. This is also from the last test. You can graph these. You can graph square root of x and graph -2 square root of x minus 3 plus 14, and that might help you figure out what these transformations are. But the way we actually did this is we said each of these things in our formula is telling us something. So a negative outside of our function means we reflect across the x-axis. A number in front makes us vertically stretch by whatever number that is. Inside, if we're adding or subtracting, that's part of the super secret opposite society. So instead of -3 meaning left 3, it actually means we shift right 3. And then finally, the plus 14 on the outside moves us up 14, which is actually why this is difficult just by looking at your calculator, because it may not even show up on your normal window because of that plus 14. You might have to actually zoom out or whatever. That was 21. Let's go to 22. This is from the worksheet we had on linear and angular speed. And so what you need to know to get from 25 revolutions per minute to radians per second is that 1 revolution equals 2 pi radians. Because a circle is 2 pi. So I start this off, and those of you who have had chemistry or are in chemistry, this is like dimensional analysis. Also, if you're like, I really don't remember us doing this, Miss Klassner taught you this while I was gone. So we start with 25 revolutions per minute, and then we're trying to get to an end result of radians per second. So to cancel my revolutions out, I need 1 revolution on bottom and 2 pi radians on top, so that those cancel. Now I need to go from minutes to seconds. So I need 1 minute on top and 60 seconds on the bottom, so that my minutes will cancel. Because now my units are radians per second, which is what I want. So if I multiply out the top without my calculator, that's 50 pi, and on bottom that's 60. This is radians per second. And then if I actually get the decimal for that, that is 2.618 radians per second.
Do you have to have decimals?
You don't have to have decimals. If you're going to leave it as not a decimal, you would need to simplify the fraction and make this be 5 pi over 6 radians per second. I am fine with either of these two answers. Whichever you want to do. Yes, Erica.
Are we going to have to know 25 revolutions is 1? I mean, are you going to have like a little...
That's what they gave me in the problem. They gave me 25 revolutions per minute. So yeah, you'll have to say, okay, in this problem, what did they give me to start with? They gave me 25 revolutions per minute. Now 23, we're using the information from not 24, 22. Sorry if that threw anybody off. I deleted some problems from this review and didn't pay attention. When we want the linear speed in inches per second, we're going to use what we got in 22. And it doesn't matter if you use 5 pi over 6, or if you use the decimal. What we start off with is radians per second, and what we want is inches per second. So how do I go from radians to inches? I have to use the radius. Okay, so radius and radians, those sound really similar because that's how we get radians, is we're talking about the radius of a circle. So what we want to do is times by our radius, which if I look over here, 15-inch diameter means my radius is 7.5 inches. That is equal to 1 radian. And I don't need the rest of that line because that's inches per second. If it had asked me for a different time unit, then I would have to do more than that. So I just need to do 5 times 7.5 over 6 with a pi. So if you leave, like, this is where the decimal is actually really a better answer. You either get 37.5 pi over 6, or if, as a decimal, this is 19.635 inches per second. And you might go back and look at that worksheet if that seems really unfamiliar to you and try to work out some of those problems again. 24. You're supposed to mark out the cotangent part of that because that wasn't really supposed to be there. Find all 6 trig functions based on this triangle. So we need the third side of this, so we have to do the Pythagorean theorem. And when we work that out, we get that x is 12. And so we're going to find sine, cosine, tangent, and the other ones. All right, so sine, it matters where our angle is. So opposite of this is 12, adjacent is 16, and hypotenuse is 20. So on sine, opposite over hypotenuse, 12 over 20, I can simplify that and get 3/5. And I would rather you write 3/5 than 12 over 20. Cosine is adjacent over hypotenuse, so 16 over 20, which reduces to be 4 over 5. Tangent is opposite over adjacent, so 12 over 16, which is 3 over 4. And then we just flip those. Since we already simplified, if we flip, then they'll also be simplified, as long as we flip these answers instead of what we had before. So 5/3, 5/4, and 4/3. And on 25, I asked you to mark this side is x and this side is r. And we're really just needing to find x and r. So this is the only time, by the way, that it matters what mode our calculator is in for this whole test. This is the only question it matters. And you need to be in degrees because the angle they gave us was in degrees. So what I'm going to do is to find x, I have to think about what sides these are. This is adjacent, this is opposite, this is hypotenuse. So if I want to find x, I need to use opposite and adjacent, which is tangent. Tangent of 51 degrees equals 4 over x. Now, the way I solve this now is I'd have to multiply both sides by the bottom, which is x. So x times tangent 51 equals 4. So that means I need to divide both sides by tangent 51. So I was grading homework that was turned in yesterday, and a bunch of people just timesed by 4. That's not how that works. If the 4 is on top, I need to do 4 divided by tangent 51, which gives me 3.24 or 3.239. I don't care what you round to as long as you don't round to no decimals or 1 decimal. So I want 2 or 3 or more, but 2 or 3 is fine with me. But we should not be rounding this to 3. And well, it says nearest tenth. I guess I would take 3.2 because you were paying attention and I wasn't. But that's not really the point. To find r, you could use the Pythagorean theorem, but if you got x wrong, that will mean you get r wrong. So you could instead say that that's opposite and hypotenuse, so that's sine of 51 equals 4 over r, and then do what we just did. The number is on top, so that means that I need to do 4 divided by sine of 51, which gives me 5.147. And that is the review.